Hi, I'm Nogueira, and I have with me Matthias Kaiser, and I need to read it. You're Chief Architect in the area of semantics and natural language processing. So, Matthias worked in several universities, in Stanford, in Berkeley, in the German Institute for Artificial Intelligence, and you have a PhD in linguistics. And you work here in the technology strategy team of Kaiser, right?
Yes, thank you for reminding me of all that.
No, I mean, I just want to give people a context who you are and what you're doing. So, Matthias, you're working here at SAP on the topic of semantics, together also with other colleagues. And I was wondering if you could explain to people listening to this what really semantics are and what it is and how relevant and why it's relevant for software.
Well, semantics, that is a very interesting question. It is probably 2,500 years old, since Parmenides. Well, we speak and we can write. We can speak in symbols, basically. When I, for example, say the word apple, that is a certain sound, and I can write it, and it's a certain kind of writing, right? And I can say this in many languages. And we have also the objects that are apples. Let's say it's a fruit for now. But how can we, what do we think? If I ask you, what is an apple? What would you say? You would probably tell me some features of an apple that, if I find an object that would make me able to say, oh, after all I heard from Rui, this must be an apple because it is round, it has a sweet, sour taste, its color is green or reddish. So this is an apple. So we have three things. We have a symbol, the word as we speak it or write it, or in which language we communicate. Then we have the thing itself, and then we have some kind of description or idea what it is, that we can, that we can distinguish it, say, from a pear or a banana or pairs of shoes or something like that.
Yeah.
Now, interestingly, for example, there might be a very different meaning of apple, a very different description of apple. We can have an apple, and what we find as the thing itself is a computer. It's also an apple. And you would not describe it as having a sweet, sour taste. I never tasted a computer.
I did. It doesn't.
It's not sweet, sour?
No.
Okay, then it's not that apple that I described before.
Okay.
So it must be something very different. And the semantics is concerned with those descriptions that help us really distinguish objects, not as we speak them, because it might be ambiguous, but as we can distinguish them in the real world or in the virtual world. The virtual world being the software world then.
That would be my next question. So how relevant is this now for the software world, so to know this?
Oh, this is incredibly relevant in the software business. See, we have today many different levels in the software. We have many systems that have to communicate between each other. I might call the thing an apple. A software system might have stored things about an apple under a certain number, ABC 1, 2, 3. But the semantics should be the same. In the end, I would like to say, show me all the apples. And the thing would say, okay, apple, what is for him an apple, the thing that is described by certain properties, is for me under the name ABC 1, 2, 3. And we both reach a common understanding about that we mean the same thing, even if we describe it very similar. And this is something in software, many systems using different representations of things may mean the same or similar things. And it's very relevant to bring these things together, to integrate the information.
But isn't that a huge amount of data that you would need to really make the system aware, well, not aware, but giving the system possibility to know, to take the example, what an apple is?
Yeah, now this is a very interesting and even more relevant almost question, because how do we do that? These descriptions are not just symbols, they really are systematic descriptions that distinguish all the objects or the virtual objects we have to deal with. And how can we do that? The real answer to this question in the end is that systems or software has to become more and more capable of arranging these descriptions, disseminating these descriptions from what is already stored, and evolving these descriptions with time, so that it always has an accurate description and people do not have to maintain this semantic layer, this meaning layer, these kinds of descriptions by themselves, because it's a huge amount of data, and we want to lower, as software producers, we want to lower the so-called total cost of ownership at the customer. And for that, we think semantic technology is a good idea. What we need, though, is we cannot ask a customer of ours to say, now you get semantic technologies from us, and for that, please employ 3 more PhDs in semantics so that they can maintain our system. We have to provide the means in our systems that it is easy to evolve the meaning layer of our system.
Yeah, so also that systems maintain themselves
exactly.
and learn themselves
exactly.
On semantics.
Exactly. The question of self-evolution, self-learning is very, very important, because humans will not be able to cope with this kind of complexity that takes place in the systems. You know, if we think what we have in mind today and what we are preparing, new DB, right? Things like we can now today talk to the whole wealth of information of the whole company from a user interface, basically. And this is such a huge amount of information where we have to disseminate the meaning of the information, and which no human will be able to maintain explicitly.
I think we should do another video with you to talk specifically about this self-learning machine. So first of all, for now, thanks Matthias for explaining to us and give us a rough overview about semantics and what they mean. And we will see you again, maybe in the next video, where you could talk about more on this self-learning semantics machine, let's call it this way.
It will be my pleasure. Thank you very much.
Okay, thank you. See you guys, bye-bye.